Hey there, this is Richard Rahn, and I wanted to share with you the simulation tool that we're using in this webinar so you have some idea of what's going on behind the scenes, since to include this in the webinar would be quite a bit of time, more than we have probably, and then we wanted to avoid the technical challenges of showing this. So we're going to record this and let you take a look at it offline or at your leisure. But let me share with you how this works. This is an Excel-based simulation engine that was developed by a colleague of ours at the Kaplan Business Group. And it is not a static simulation tool. It's actually dynamic simulation modeling, the way you would do it in any commercial simulation package like ProModel or Simulate, those kinds of products. And it basically breaks the simulation project into two pieces. One is the data, and then the other is the engine that does the calculations and shows you the results. So what we're looking at right here is the data side of it, and you can see these tabs down here at the bottom. We have a number of different types of data that we need to enter. So let me just walk you through one of the simulation models that we used in this webinar. It's actually the one that adds variable work time. So it's one of the earlier ones we did before we started making a lot of improvements. So let's take a look at this. We have first the flow description. So we have a flow. Think of this as a routing with the code name main. And since we're designing a cell here, this is the only one we have or we need. We don't have any feeder lines or other kinds of flows, other kinds of options. Every time there's a difference in the flow, you'd need to define a separate flow on this page here, but we only have one, so that's pretty simple. We have our cell called main. And then we have resources. I'll just click on the resources tab, and the resources that we have here are the workstations, so we have 4 of them. And we're calling these final or fin 1, 2, 3, and 4. And then we have another resource which is an operator, worker, and we call that oper 1. And we have 4 of those. So we have 4 people, and then we have 4 workstations. The capacity is 1 unit at a time. We can't do more than 1 at a time in these. And then we have some other options that we are not using for the most part in this simulation, but that are available to us. Travel time to an IPK in Process Kanban. Number of IPKs, we will be using that a little bit later on. Number of buffers after the workstation that can store a finished piece. Return time, so we have some time that we can add here for travel. Variability, this is one that we normally would use, but we're not using in this webinar. I'll just click on this. That lets us add low, medium, high, or none. The reason we're not using it in this webinar is just to keep the number of different variables down to a smaller number. And then we have some parameters here. Do we want to report the results out? In other words, do we want to collect data on this? And then do we want to show this in kind of a rudimentary animation, each of these resources? Then we go to the flow. The flow is the routing. Again, so we have the flow which we defined earlier as main. And we show here that fin1, workstation 1, connects to workstation 2 over here. And the resource that's going to work on that is operator 1. And then fin2 goes to fin3, fin3 goes to fin4, fin4 goes to hash mark exit, which is the symbol in the system to indicate that's the end of the line. So we have the same labor category, operator 1. Remember, we have 4 of those. And then there's some room for branching. We won't be getting into that in this model, but it's a nice feature to have in the model where we can have a left or right, branching with a probability. And then the system would randomly, based on that probability, send it to one side or the other, and then room for default labor times. So very good. That's all we need here. And then we go to products. So in our webinar and in the simulation model, we've defined 10 different products. So the code could be the part number. You see here, the part number we've identified as just a letter of the alphabet, A through J, and product description. And then these products are all going through the flow main. So if you had different flows, different products had different routings, essentially, this is where you would identify that, assign the product to the routing. Then we have process times. And for every product, then, we have 4 workstations, right? So for every product, we would have to define the work content that takes place at each of these workstations. Now, these times don't have to be the same. Again, we're trying to reduce the variability so we can work on 1 or 2 things at a time. So the labor time for A is 0.7 per station, and for part or product B, it's 0.3 minutes per station, and so on and so forth. So C is 0.8, so 0.8 would be 3.2 minutes in total for that product, the total work content. And I just scroll down here all the way to J. The highest work content product, I believe, is J, which is 1.5 minutes per station, adding up to 6 minutes of total work content. The variability, by the way, is the lowest is 2 minutes, 0.5. So that would be product I, and the highest is work content J, 1.5. Notice also that I've staggered them. So I have a lower work content, higher, lower, higher, lower, higher. So we've done some preliminary kind of sequencing. Now, the last tab that we need to complete before we can run the model would be the sequence. So that's essentially the production schedule. And what I've done here is just listed all the products in order and then started over again. And units 1, 2, 3. So we're going to build 1A, 1B, 1C, 1D, 1E, 1F, 1G, all the way to J, and then we start over again with A. And this will go. The schedule here, the sequence is extensive enough so we're not going to run out of orders before the end of the working day. And I'll show you how that works in a minute. So that's all the data we need. And what we're going to be doing in the webinar is just proceeding forward and modifying this data and adding things like changeover time and changing this 1 to some batch size, etc., and experimenting with those kind of things. Now, the engine itself is again built in Excel, and there's a lot of Visual Basic code behind this, but basically we will run the model and then we'll look at the results. And this is what you're seeing here, results from a previous run. So when we're ready to actually run the model, validates a nice button to click, and that just does some checking of your data, looks at that data sheet and makes sure that everything is okay, and it says here that there are 0 errors found, so we're in good shape. And then I click on the simulate button, and what this allows us to do is have a JPEG or a bitmap of the line layout. The animation here is rudimentary, so don't expect to see 3D, objects, products, and workers walking around. You're not going to see that. But it's a rudimentary, or simpler, I should say, animation that shows us the status at each of these stations. So fin 1, fin 2, fin 3, fin 4, and they will change color based on the status. So green is busy, red is blocked, purple is waiting, in transit, idle, partially full, full, etc. So these are going to be changing colors. Now, if you were debugging a more complex model, you could really slow it down with this animation speed we have here and just watch as the orders are processed through the system. Data file lets you select the data file. So what I've done here is created multiple data files for this webinar. And then we just select the one we want to use, and then we run it. Graphics lets you change the JPEG. Now, what we're going to do for every one of our simulation scenarios is let the line warm up for 15 minutes. Warm up means start building products so that the line is filled, but don't start collecting data yet. And then at the end of 15 minutes, start collecting performance data, and we're going to run these for what we're calling an average shift of 420 minutes. Okay, last thing to comment on is animation. Needless to say, to maintain all the animation and status requires more computing horsepower. And so if you don't really need to see the lights flashing, you can turn animation off. And then it runs literally about 10 times faster. But let's leave it on for a minute, and then I'll turn it off, and you can see how this works. So I just click on Run, and it opens the data file, and then it starts running. And of course, it's running really too fast even at this rate to really see what's going on. But it's keeping track up here of the number of units completed, and it's keeping track of the status of each of those 4 stations over here on the right. And we have a status bar. It's almost done, so we'll just let it continue. And when it's done, it comes back here to the results sheet. So on this particular run, it says runtime. We need to change that to date, I think. But here's today's date. And then we have a warm-up time, 15 minutes, runtime of 420, and then completed orders, 296. So in 420 minutes, we completed 296 units. It gives us a status here of each of the products and the number of units completed. Now, if I click on this resource tab here, this is going to give us some valuable information we're going to use in the webinar as well. It tells us the utilization of each of these operators. So we have one operator category, operator 1, but this breaks it out for us. So operator 1, second person, third person, fourth person, and it shows us the percent busy, the percent that they're actually working, and then the status of times where they're not working. Now this was a situation where we had idle time coming up. So 19% idle, 35% idle, 25% idle, 39% idle, meaning nothing to do, waiting. We could have had situations with blockage and percent waiting, etc. So idle time is no work, essentially. And how many entries came into those operators. We also have a status of the utilization of the workstation, which was 70%. So we have some opportunity there. Blocked 30% of the time, 25% of the time, 21% of the time. So this is going to give us good information, not just on throughput, but on utilization of these resources, workstations and operators. So that's it. What we're going to do then is go through a variety of scenarios, starting with a very simple one and then building on it step by step. This is, I think, probably the second one that we do. And then we're going to add, as I mentioned, things like changeover times, which are going to be very important, and then we're going to experiment with applying the balancing tools of mixed model line design. Eliminate waste, add resources, add buffers, IPKs, etc., and try to get this completed order or throughput up to the number we want. This was not the design number. We're not hitting the design target yet, so we need to make improvements to the cell. That's the whole purpose of this webinar. So I think I'll end it there. That gives you an idea of what's happening in the background, and we're very excited about the use of this tool, actually, because it's a simulation tool that is not going to do everything for everybody. It's certainly not competing with the more full-featured, robust commercial packages, but it is doing real simulation work, dynamic simulation modeling, and for many of the challenges we have, this is perfectly sufficient. Right? It meets our needs for being able to fairly easily create a simulation model without having to be a complete expert at it. Learning curve is relatively short. So I'll end here, and we'll be in touch.